All right, so let's go ahead and get started today. Uh, Welcome back. Good afternoon to everybody on my Twitch stream. Really appreciate you checking us out and hanging out with us on this Sunday afternoon. So we'll just get right into it. Yesterday, the last stream, the last video for the YouTube viewers, we ran through the test procedure and got most of this filled out. Yeah, we wrote some real quick firmware for the temperature sensor using the ADC inputs. The one shot, it's not perfect, but it does prove that the temp sensor works. We just have to create the code to scale it appropriately to read it for the final application. Right now, it's no big deal. We determined that it's roughly within the values that we're looking for room temperature. What we were getting off of the multimeters internal temperature sensor and the contactless infrared thermometer. So we'll go with that. Again, that code needs to be cleaned up, written better, but we don't need perfection with it because it's just going to be a general sensing to help control the fan, to help keep the stepper driver from overheating. So we also ran through all the inputs, seem to work properly. Got some code slammed together for that. Now we're going to work on testing the PLC out, but we got to throw together some code for the PLC. So what we're going to do is pull up the Click programming software. So there's going to be a new folder in the basic modules directory, firmware, PLC firmware. I think I've got an official name for it. So let's see if I can find that official name. So let's open this with code. Shouldn't get too mad. Project, firmware, basic modules, PLC firmware. So let's see here, test plan. So if we go back to VS Code for the test plan. So this is going to be the name of the firmware. So let's go here. We're going to start a new project. All right. So the click is C201, 01 CPU. Okay. Right. Disabled password. Okay. All right, so we got the new project. Let's go and get it saved project as. And let's go to see if I can find the video series. Here we go. Okay, I hate that. It does that sometimes to me. So the project as. Let's see if that fixes it. There we go. Projects. There we go. All right. So let's go back in here, get the name. All right. No spaces. Okay. So we've got the project saved. That's cool and all. But one of the things we need to do that's also important is, let's get over to the camera, is we need to get things kind of plumbed together. So, so for now, we got to get these guys wired up to the proper terminal blocks, the outputs, and the commons tied in. And I've got numbers. We're going to do this right. So I'm going to kick off this guy. I don't care. I'm going to kick off the... And we're going to get this kind of plumbed in and wired up properly real quick. Should only take a couple minutes to properly do, but we're going to do it properly with ferrules and all the fixings and the proper, color code for signals, which is 18 gauge blue. So we're going to need two primary. So we're going to need the input controls, 3 of them, which would be 1, 2, Y1, 2, and 3, because they're outputs of the PLC. 1, 2, and 3 for the limit, and 4, 5, and 6 for the controls, and then the 2 commons, which are going to go to the positive block over here. So one of the things we want to make sure of, let's just go ahead and disconnect some of the stuff off here so it's easier to handle, is the jumpers are not engaging the common ground, for the limit or the control commons, because we want them to be isolated to here. So that will completely isolate the input from the output. So with that in mind, let's go ahead and get that guy out of the way. So terminal block. So let's go ahead and kind of figure out our wire length. We're just going to kind of swag it, get us extra. And then we'll cut these guys. So we need 6 of these. Just cut them all the length. That way we have enough to work with, and we can create service loops inside the wireway. I'll show you that. They ain't got to be perfect. So these will be for the main signals. That'll go to the terminal block for the outputs, the Y. 2, 4. 5. I'm just kind of flagging it. Again, doesn't have to be perfect. Got that guy. Move our board out of the way so it doesn't get damaged. We don't need all this junk in our way. I like to use things like this to catch clippings and waste in. These guys off of Amazon, there's different brands. Automated wire strippers. These things are a lifesaver when you're doing work like this. As you can literally if things want to cooperate, create like a bouquet of wires and just go through and smack them down. And because you can control your length, your strip length, you ain't got to worry about fighting a pair of wire strippers. It's one of my little cats saying hi. So get these ferrules on. These are 18 gauge. A lot of times you'll see them in red, but actually you can order ferrules in multiple different colors for the different gauges. A lot of times they're color coded specific ways in these kits. Like A lot of times red is typically 18 gauge, but again, you can get them pretty much any color you want. Just another crimping tool. This is a 4-sided crimper. Just jam through them. And then we switch over to the other side. And we just slam through them as well. Not too worried about the little mess with the insulation. That's not really that big of a deal. For one thing, it's not conductive. I'll just sweep that up real quick with my hands once I'm done with this. Little shortcuts, little tricks you learn after working in the automation sphere, putting equipment together. For wiring up signals and stuff, especially logic and I/O like this, precision isn't necessary. For one thing, you're not high speed. This is basically logical on and off and providing basic power for signal logic. Industrial automation is pretty forgiving with its signal logic. It has to be. Consider the noisy environment. All right, so one of the things I found out that with terminal blocks, a lot of times they don't like the full depth. So let's back these guys out a little bit. They don't like the full length of the, you can, but it looks hokey. It leaves a little bit of the metal hanging out. So I call every one of these little guys where the crimp tool leaves a mark. I just call them knuckles. So I usually just trim back the first knuckle on all these guys. So they properly fit in the terminal block without the overhang. Okay, so those are our signal lines. Now we need to kind of move this out of the way. Let's kind of go ahead and get some wire for our power, which will go and bring up the same wire away. Go ahead and just cut 2 pieces. Again, we're just swagging it. No one cares because I'll show you what we do. All right, same thing. Barrels. Actually, the longest part about this is throwing the wire numbers on. Because one of the things I want to do is also document the test fixture. Because it is part of the process. And I'll create like a wiring diagram for it. Just in case. And I'll have all the wires numbered on the diagram. So, I get a mess here. Throw that stuff away. Set that aside because it's my power. Get that out of my way. Now we're done with this stuff. Wire. So, my wire numbering labels. I already labeled all the ones already on the fixture. I'm just going to use the rest of this up to kind of go with this as like one centralized project in itself. So if I use this for other things, I'll use up the rest of the numbers on other ancillary components. So we know we need 3 signal wires and 1 power wire. So let's just kind of Now, figure out which side we trimmed. This looks like the trim side. Yep. So this will be the terminal block. So, kind of stick them out of the way, grab one. Now, looks like one long label. It could be used for one long label, but in fact, it's split. Start winding that around, and it comes right off. So it's going to come out the top. Y1. Okay, well, before I get too far ahead of myself, the wire way open up. So yeah, like I said, this is going to take the most time, is doing this neatly. Getting the wire label on, winding it around a couple times, tearing it at the split. Now, there's some really nice systems out there for labeling. Some really nice stuff out there. But they are a little bit more expensive, and I typically don't put control panels like this together too often, so I don't mind using these type of labels. So that's perfectly okay. All right, so why did you go out of focus? All right, there you are. So, I don't know if you've caught on, but yes, I do have a way of labeling. So, you can see that. So that goes, so if you're reading like left to right, and then you follow down the wire, it continues the trend left to right. Because the general idea is, if you're looking at the terminal block from this orientation, the wire's coming from the top, you're reading it out that way and then reading it into the terminal block. So let's go ahead and get these guys plugged in. And yes, there's typically a torque spec on these, but I'm not too concerned. So the idea in the long run is, you know, I can leave this all wired up, these connectors for this test fixture, and then down the road, you know, that way I can just grab it and go. Even if I have to pull these and set the connector block aside, I can plug them back in because, like I said, I'll have a wiring diagram and everything else that goes with it. Now we're going to take care of our power. Since we're going to bring it out the top, we're just going to follow the same routine. Come in here. So remember, because one of the things, I don't know if you remember, I don't know why I said so remember. So I don't know if you recall. So when I was explaining all this before, so now that should be good. I have service loops. I have plenty of play if I need it. We'll get that tucked in a minute. So the outputs on here are technically not outputs in the sense that you might think of an output. This particular unit, these are common drain output. In other words, they're basically low side. So when the system activates the output, it actually connects this, the blue line, to technically ground. So basically what we need to do is our common on our inputs need to be positive, so they come into the opto when the system triggers when this guy triggers its transistor output, it'll come in, pass through the opto, and come into this wire through here and out through the PLC to common. So it's kind of backwards. That's why you don't want these guys connected to ground for your common lines. So basically, this is the first input wired up to the PLC. Now let's go ahead and grab another subset of wires here. Go and get this guy put together too. And we're going to make this a little bit neater when we get to it. And yes, it does help to kind of go in sequence with the numbers. At the end of the day, it doesn't really matter. You look online, you'll find all these different theories on numbering for this process. Can't say I'm 100% sold on all of the methods out there. There we go. It's in. Open these guys up a little bit. Yeah, I don't want to eat up a lot of time doing this, but you know, it's part of the process. Something has to be done. We'll get to programming. But we need this before we can program. And I know there's probably maybe some automation guys out there watching this like, what the hell is this guy doing? He's smoking crack. And that's perfectly fine. The way I learn versus the way you learn, different people taught me. And then I had to do a lot of teaching myself because the knowledge I gained was kind of fragmented anyway. So I had to fill in the gaps on my own. Because that's one of the problems is knowledge islands that form in a lot of places. That's one of the things I want to try to avoid. It's another purpose of this video series. And the other ones I want to get to. No, come on. Don't fold over on yourself like that. There you go. That'll work. Is that knowledge islands are bad. It's a form of job protectionism, and I don't agree with it. I'm just going to be blunt. If you want to protect your job, just do it right. Don't hold knowledge back, because that doesn't protect your job. It really doesn't. The best thing you can do to protect your job is just do it right. Knowledge hoarding and knowledge islands don't do any good for anybody. They're actually very damaging for an organization. Especially because you're all supposed to be on the same team. You're all supposed to be working for the same goal. You know? You want a bigger paycheck, do something that's worthy of the bigger paycheck. And typically, that's just do your job. Under. All right. Come around. This won't be the cleanest, won't be the neatest, but I'm not aiming for that. All right. Got all these guys wired up. I can close that. Don't want my cat's knocking it over. Okay. So. Got the terminals all wired in, so let's kind of figure out how much room we actually need on this. Give ourselves plenty of room here. We want to be able to have play, just in case. Actually, what we could do... Let's go and start getting these guys into the wireway. I love working with wireway and stuff. It's like some of the coolest stuff to organize boards like this. any test fixture can benefit from wire away, and this stuff's relatively inexpensive off of Amazon. Well, yes, there's some big name brands. Does that work? No, that doesn't work. So we'll just kind of bring it out here. I mean, it does, but some of these... I don't want to spend too much time trying to get this looking perfect and flowing perfectly. So what we can do is kind of... The great thing about PVC wire is you can flex it pretty good. You can bend it and it'll hold its shape. One of the things I really like working with it, the PVC jacketed wire. And we could probably do other fancy stuff to make this look nicer and to flow better. But I'm not really aiming for that right now. Just kind of get the service loops in there. All right. So one of the things we can kind of do, just kind of do this. And do that, little fella. There we go. Actually, if you kind of wanted to, you just do this. Bring them all out. There we go. Not perfect, but it does the job. Hold the board. Plus, that'll give us enough play so we can just disconnect them a little bit easier. Okay, we're done with this guy. I'll put the wire way back on. All right, here we are. Okay, I'll start plugging this guy in. Boom. Main power back in. Okay, that guy can go. We can bring this guy back up. All right. So one of the first things let's go ahead and do is let's get the input test firmware back on the unit. Make sure we're still COM23. Yes, we are. To flash. Just go and put that back on there because we're just going to need it. Okay, status LED went off. Oh, well, you can see that. So let me leave it. Okay. So one of the things we're going to do, we can, do I have a jumper wire here real quick? No. So yeah, these are a little sloppy, but that's fine. That's fine. There we go. Forgive my, yeah, I'll get all these numbers written down and figure it out later and get a diagram written up. Put up. So now our inputs are completely on an isolated power system through the PLC. And that's one of the objectives of this design. So let's go and minimize this guy. I've got the program name. So now we get to try to figure out a PLC program. So when it goes into run mode, I was going to throw in a button. So basically it needs to So we need to put an output. So a timer number. Let's go T1. Okay. Set point. Milliseconds. Okay. Okay, set point is going to be DS1. All right. In milliseconds, it's going to be an off delay timer. So basically, when it starts high, so let's see here, output. So what we need to do then is, hold on here. Again, I'm just learning this setup and trying to teach myself PLC. So I think we have to data view. No. Where do we go to here? All right. DS1. DS. There we go. DS1. Initial value, we're going to say 500. Let's see here. So according to the firmware, did I seriously close the wrong? Yeah, I closed the wrong thing. I wanted to look at the firmware. Because we need to make sure that, okay, so 2000 milliseconds here. So 2500 milliseconds. So 2500 milliseconds. All right. Output. So it should be current. Okay. Because once we figure this out, figure out for one of them. We need to. Okay, so that's going to be Y1. No. Output. So I needed to control. Basically, I need Y1 to engage. So basically, the program starts running. This should engage. And then it should delay. The output should latch. There's a. No. Do that one. Okay. Put that here. Yeah. So the thing is yeah, when I was in electronics class, so I went for electronics engineering, and we didn't really cover anything with PLCs or any of that, or any logic like this. Um, the engineering classes really have changed over the years. So electrical engineering does technically cover PLCs, while and I never had a chance to go to any classes for PLC, so I'm trying to learn it myself. So if that, okay, so I may have to put a contact there so it enables, it should enable. So let's find out here. PLC. Um, See if it'll compile and Tom 18 click blah 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 blah. Connect. We are in stop mode. We should be on. Don't read the project from the PLC. No, PLC. So program. Oh, here we go. Right project. Okay, so it's not complaining about that. Yeah, I know there's differences. Let's shove it in. Run stop. Not doing runtime edit. Let's shove it in. I don't really care what it does, but I got to figure out what output it's not. Okay, so it's not doing anything there. It probably won't. I think we can monitor status. Oh, it won't run anyway. So let's put it in run mode. Okay, so there's nothing enabling it. Maybe we need to do a button. Well, let's take my button box. Well, maybe. Oh, wait a minute. Hold on. Okay. Okay, so the output is being held high. So we got to figure out. Okay, do we need an input? Let's put it on X1. Okay, X1 has an input. So let's go over here. Let's throw in a, it's going to be X1. Rising edge. Okay, turn this PLC off. So we're going to write project. So I put my little button box in. Well, it does its thing. We'll switch over to here. So take the little button box, hook it up to X1. I don't know if you can, yeah, I don't think you can see that. Let's see what she does. All right. Turn the power on. We're running. Status. Okay. All right, so that part's working. So it does get turned on. So I'm watching the program here. So that's the set point. And then if I put the PLC in run mode, hit the button, the output does go high. It does count down and the output turns off. So now I need to make sure that, I think I've got to somehow figure out how to cross the rungs here. Get the output to get this tied in up there. Oh, wait a minute. Maybe I need to do T1? No, I can't. Cancel. Oh, okay. So, all right. Well, we're getting somewhere. We're going to need to set. All right. Unless what we need to do is maybe we need to put in that. Ah, there we go. T1. Okay. And out. All right. So what should happen? Okay. All right. So I think I may have figured it out. So we hit this one shot, basically the momentary button. It should activate this. The output should go high and start counting down, which will basically engage this normally open contact, which during that time, okay. Okay, so let me turn the PLC off. Let us write the project. And then flowing like a river And then I think I'm getting the logic in my head about how we need to follow through with this. So we transferred it over. So we're going to put the PLC in run mode. All right. So the output is not high right now, which is good. So we're going to status, watch it. So when these turn blue, that means it's high. It's active. So right now, that should turn blue when I push the button. Then this should turn on because that's edge detect. This will turn on, which will kick this output. And the status LED should do the single flash. We might have to adjust the timing, but that's fine. So let's push the button. And it works. And I think we can constantly cycle through it. Okay. So that does actually work. We're going to stop the PLC. What we're going to do is cancel. Oh. It's not the address picker. I was just in it, and I'm in. Is it the address picker? Oh, DS1. There we go. So let's go. All right. We need to stop the PLC. Back to here. We're going to write project. Go to, just going to compile. So I'll see what this does, and then I'll flip over to the webcam. Yeah, things took a little longer, this video. I might push it to an hour and a half, depending. Because I imagine once I get the logic figured out in my head, okay, so it's pushed over. We're going to start running. Monitor, let's see. Run mode. Go. Be in run mode. All right. Oh. Status. All right. All right. So if we go back over here to the webcam, let's kind of pull this guy a little bit further into view. So the status LED should only blink once. So even though the PLC is only holding it for a period of time, because of the way the program is written, remember when we let go of it just triggers it. So what we'll need to do is so what we need to do then is here, get rid of the end. Let's stop the PLC. We're going to delete the end. The end is gone, people. The end is gone. So we will have to, when that turns off. So I might have to adjust that delay time to match here, 2,500 milliseconds. Or we'll have to play around with it, because basically we wanted to go through and trigger each input in sequence. So what we're going to do then is here, we're going to throw another timer, and it's going to be T2. Set point is going to be DS2. All right, it's going to be an off delay timer. Okay. And what it's going to be is edge contact is going to be off of, I think, Y001. Oh, Y001. We're going to start it with the falling edge. And then, so we need to go to, so it should be, no, set point should be DS2. And then that's going to kick on a normally open, which is going to be T2. And that may be a more efficient way to do this. And then here it's going to be an out. And it's going to be Y02. And then let's throw an end in here. So let's go adjust. Let's go set DS1. Let's see. Add sticker. So let's go set up DS1. So its timing might be a little bit different, but let's set up DS2 to 1,000. All right. Again, we'll have to okay, we're going to okay. Write the project, no errors, no warnings. Go back to monitor. Oh, get this done. Compile it, shove the data over. We're gonna have to play around with the delay values a little bit to get it to be just right, but I think this is a logical flow of how this is going to work. All right, we're going to go back to monitor. We're going to, what's it was over here? There's a status monitor over here. Oh, it's under home. My bad. Status. Hey, little cat, stop. All right. So reset. So again, what it's supposed to do is mimic this. Flash once. Every, again, we could tweak this program out too. And then limit 2, flash twice, and then wait a long pause off. So it's basically just going to be mimicked like if we were tying them all one at a time. But, so let's put the PLC in one mode it is. So it should be flash once, long pause, maybe flash again, long pause. And then 2 flashes. So let's see what happens. And then nothing. Why aren't you working? So let me look at the logic. Y02. Okay, so the delay might not be long enough. It might actually be missing it. So we might have to turn that off. Go into address picker here. The D series, the DS. 100 milliseconds. And then 3,500 milliseconds. I think my timing's off, but that's fine. All right. Going to write project. Yeah, again, it's going to take tweaking out those settings. Little cat. You. All right. Might be sloppy logic, and those watching this that know PLC is better than me, feel free to point them some things out, give me some advice. I'm more than happy to accept positive criticism, constructive criticism. I'm not perfect, and I'm trying to learn this on my own. Again, going by whatever limited knowledge I've had. All right, so we're running. Let's watch the status. And then 1 flash. Still only 1 flash. 1, 2. Okay. Okay. All right. 1 flash, long pause. 1 flash, long pause. And then 2 flashes, long pause. Okay, now we can tweak around those values, but that is showing that input 1 is being kicked off, and then followed by input 2. So what that means is our logic is actually working. Get rid of the end, because now we have to put a new timer in. And we're just going to timer 3. And set point is going to be DS3. It's going to be an off delay timer. Okay. So then we have to put a normally open contact in here. And that is going to be Y02. Hold on here. No, it's going to be edge contact Y02. Falling edge. So when this guy turns off, this guy turns on. And then we're going to need a contact normally open to come off of T3. T3 kicks this guy on, and then there's going to be an output to Y03. Y03, okay. Now let's go ahead and set DS3 3 and 4. DS3. So we go back to our code. And it's 2, 3, 4, 4,500. Again, these are all starting points. Okay. Okay, it should save. And the output. And then now let's go ahead and throw in another timer. It could be T4. Set point is going to be DS4. Give me another off delay timer. That is going to get a edge contact falling edge off of Y. I have to fix the one above it. So it's going to be Y003, I think. Hold on. Let's put my logic here. Edge off of Y1. This should be off of Y2. And then this should be off of Y3. Okay. Put this on. And now we need a contact normally open off of T4. And then output on Y4. All right. And I think DS4. So that will be 2, 3, 2, 3, 4, 5,500. Okay. Let's just go ahead. All right. Five. There we go. Off. Here will be an edge contact. Falling edge off of Y04. Y04. And then here it's going to be an open off of T5. And then output Y05. And one more of these routines. Y05. And put Y06. is going to be T6. And then here, got to put an end. Make sure the PLC is in stop mode. Right project. Hasn't puked out its guts yet, so I have at least learned something with PLC programming. Push the project over. So hopefully we'll get the flash sequence again. As long as we get the proper flash sequence at the end of the day off the board, that's all that matters. That just shows that this worked. All right. Put it run mode. Nothing's going on the board yet. Let's go back over to the webcam. Single flash. Okay. 1, 2, off. 1, 2, 3, off. 1, 2, 3, 4, off. 1, 2, 3, 4, 5, off. 1, 2, 3, 4, 5, 6, then off. Yes. All right. So we've successfully validated the inputs do operate off of PLC logic. Mind you, I just pushed that momentary button to start the program in the PLC, and it's just running through the ladder logic, kicking things on and off. We could play with timing if we really, really wanted to. Unnecessary because we are getting the desired results. The board is operating properly. So the isolated inputs, which is basically just these inputs on this side of the opto isolator line here, is working exactly as prescribed, with a positive common versus a negative common. So this is actually doing exactly what I wanted it to do. The design, the intention in this design is working as we want. This is exciting. This is really exciting. So basically, there's a way to shrink this. Will you be able to see it? So we're still monitoring, it was still running. So if I hit the go button, again, you'll see the X001 input go blue momentarily. This is going to lag, but you should see this go blue. Then these guys go blue. So T1, this guy, and this guy go blue, which means they're active. And then as soon as this guy turns off, this guy will go blue. So we should be able to follow the chain. All right. So we're walking down the chain, the rungs of the ladder. And then it'll eventually stop. Yes. All right. Perfect. This is beautiful. I couldn't have asked for anything better than this. We had to sit together and do the wiring. Got the inputs tied to the PLC test board. And PLC. Bam. So we're going to put the final test date as today. The test results, even though we had to rework and fix some things for the subsystem tests, that we've outlined and designed and we wrote together, all the subsystem tests actually worked. Again, we had to do some rework, but that's fine. It's part of the process. But overall, Rev 1 of the board worked. We found some problems that we're going to be resolving in the second spin. Again, we're going to be adding additional test points. But before we do a second spin or anything, the next major thing is to go through the second part of the test process. Is it in here? Open the deep test plan. So these are potentially destructive tests. We'll just stick with one board built, the first pilot board, because we've already had to do some rework to it. And if something gets smoked in this test, my heart's not going to be broken. Because then we'll build a new board with the proper chip. But so we need to, there's a couple of things that we need to do together that we'll work on starting tomorrow. One is we need to design and start building the test fixture with the heavy core resistor, with a big power resistor. So we'll be sitting down and doing the design work for that together. And, working on 3D printing the plastic, designing the plastic parts and all that. So we'll be kind of sitting down together doing that. Again, I'm just bringing you along for the ride, whether you like it or not. Because it is part of the process. But again, once the test fixture is done and we kind of know it works, I'll put together like a bill of materials and a wiring diagram up for it. And I'll put it in the project directory. What I'll probably do is in the main project directory here, I'll probably create like even though it'll be separate, but I'll create another folder, and we'll kind of create as like a little project to kind of go along with this. And I might actually, we'll actually create schematics in KiCad for it with the bill of materials and everything for that variable resistor. We'll just go ahead and do it, and any parts that we use. We'll just make generic placeholder symbols and stuff. We don't really need to worry about a PCB because everything will just be kind of like hard-lined into each other, but that way there'll be a wiring diagram and a bill of materials. That way if anybody who's following along could go and pick up the same thing. Because if I remember right, the project enclosure I showed you prior, I did pick up off of Amazon. And they have some that are very similar. If you can find the exact ones, if you are following along and are able to build and purchase this stuff, even for your own use, for other projects, not necessarily this one that you might be involved with. The test fixture could come in handy for other things. Because that 200 watt variable resistor, that thing, 50 ohms, I think is what we can max out with it. So that could be coming quite handy for other projects to do power supply load testing and other things. So there's definitely uses for it. It's something I can definitely use around my shop, around the workshop and for other projects like this. But because we're going to rev the board, we're going to be running through these tests again on the rev the board. Because if anything during the deep testing shows any problems, it's going to be there. Because there are minimums that we should be able to meet. We should be able to, at minimum, load the power supplies up and get it to deliver the current, at least the maximum current that they say. Like, I think it was 2 amps. We should be able to do that. And the motor driver should be able to source up to 2.5 amps. So if your design, if the specifications of the part say they're supposed to, then you need to test the limits. So that's what that'll be good for. And then again, we're going to test the reverse polarity protection on this board. That'll be one of the last things we do. Because if it fails, we'll know. We'll know if it fails. It'll be glorious. Glorious smoking board and parts. And then reverse voltage. We'll actually put voltage into the motor outputs and see what happens. We'll use the external power supply and just see what happens. Again, I'm expecting to fry at least one board during this process. I still have to find my thermocouple adapter from my meter. I might, like I said, might just have to buy a couple from Amazon real quick. Maybe try to get them in this week before we get to that test. Because designing and building that resistor test unit is going to take some time. So at least that's going to be at least one or a couple of streams. But I intend to have you along with me for the ride, and we'll do that stuff together. And again, I'll make the files of the Fusion files and the step files available for you to learn or build or whatever, if you want to follow along. And who knows, maybe down the road, if people are interested, I can even build these units up and, put them up for sale too. It's just like a little side completely built test unit if you're interested, who knows. If you don't have the facilities to do it yourself. So, we'll go from there. So for now, I think what we'll do is we'll call it here. Let me make sure I have everything in here. Bench power supply, air thermometer. Make sure this is filled out. I don't know if I should list the PLC or not. And its benchtop power supply, its power supply unit. I don't know. I'll kind of think about that. If anything, we'll put the PLC in here and its information, because it was kind of like a piece of test equipment that we used. I might do that. I'll think on that, whether or not it should be required, but maybe it will be. Maybe we should just do that. If anything, when we go to test next time, maybe I'll just go and figure it out and just take care of it off camera and just let you know whether or not I decided to. I'll do some digging, but at least for now, all our subsystems passed, so I'm comfortable moving on to the next set of tests. So thank you for hanging out with me this Sunday afternoon, and I really appreciate it. And I hope you learned some stuff as well. It's been a blast, especially working with the PLC and actually seeing it work and knowing that it'll work as intended. So far, this design's been a success. It's not often you get a board that works first build. Sometimes you have to go in and fix a design and actually get new boards and rebuild. All we had to do was some minor rework and we were good to go. So that makes me very happy. That's not often. So thank you. Have a good rest of your afternoon, and I will catch you tomorrow.